Hello, everyone. A very good evening to all. I hope that we are live now. So, let's see how many of you guys have joined us. And those who have already joined us, I just need a quick confirmation from you guys that whether I'm clearly visible, properly audible, or not. Within few minutes, we will start our live discussion today. It's going to be very interesting discussion, and it will be specifically helpful for those people who are just started their journey in this domain of Gen AI, NLP stuff. तो एक काफ़ी इंटरेस्टिंग प्रोजेक्ट आज हम डिस्कस करेंगे एंड आई एम नॉट द अलोन ओवर हियर इन दिस लाइव डिस्कशन एज you already have seen from the thumbnail. I have with me one of the learner. Himakesh is here. Himakesh, you are on a screen. Hi, how are you? You are muted. I think you can unmute yourself.
Hello, ma'am.
Yep.
How are you, ma'am?
Hello. Good, good, good. So many people have joined us, I can see. So I just welcome you all to in this specific discussion where we have Himakesh. Now, when I was discussing with him, I get to know that he's a person who is not from even computer science background or any coding background. He told me that he has done honors in zoology, and this is something which amazed me because this is one of the question which many people usually have from me that Priya, I'm not from a programming background. Will I be able to implement data science stuff? Will I be able to get good in that? Let me tell you, he is a part of one of my ongoing batch of data science, and he is doing extremely well. So today he will demonstrate you the entire project work which he has done as a part of NLP stuff. So before going towards that specific part, I really want Himakesh that you will introduce to everyone so that everybody will get to know about you, and then very soon we will start our discussion.
Sure. Thank you, ma'am. So, hello, everyone. My name is Himakesh Krishna, and I'm currently pursuing a PG certification in data science. And one thing that makes my journey a little different is that I come from a I didn't come from any computer science background. I had biology in class 12th, and I completed my bachelor's degree in zoology honors. My interest in technology actually started when I was in class 11th. At that time, I became curious about cybersecurity and started exploring different cybersecurity tools and script. I noticed that many of those tools were written in Python, and sometimes I wanted to modify those tools for myself. And find it difficult because I didn't know programming. That was the point where I started learning Python by my own from YouTube. At the same time, I also had a strong interest in graphic design since around class 8, I think. Yeah. I enjoyed creating photo manipulation and digital artwork in Photoshop. Over time, I started posting my work online on Instagram, which led to land some freelance opportunity and later a graphic design internship. I work in the field for several months, and even I have a job offer. However, while working as a designer, I realized that although I enjoyed creativity, but I was much more excited by problem solving, or you can say technology. I felt that my long term interest was in coding, building things rather than design. But it's not like that I don't design anymore. I do design, but for myself, not for others. And I feel there's a difference between designing for myself and designing for others. And however, while working as a designer, I realized that although I enjoyed creativity, I was much more excited. As I said, I was much more excited by mm, coding and all stuff. Then around that time, I started exploring different technology domains in which I think I should step in. And then I find out that right now, artificial intelligence and machine learning are booming. So I figured out that data science is a kind of foundation for many AI and ML applications. So I decided to pursue it seriously and enjoyed the PG certification. I enrolled in the PG certification in data science from IIT Guwahati. And during this program, I learned about basic Python's statistics, EDA part, machine learning, unsupervised learning, supervised learning, even deep learning models like CNN. And we also completed natural language processing, and currently we are moving towards the transformers. And this project is one of the outcome of that learning journey. It is especially meaningful to me because it shows that even someone from, you can say, geology background can successfully transition in data science with consistent effort and consistency. And thank you. That's all about myself, and I'm excited to share my project with you.
Amazing, amazing. I hope that many of you guys will be able to relate with the Himakesh journey. At least I encounter multiple learners whenever I host any event or whenever I meet the learners. They say to me that Priya, I'm not from the specific background. Even the working professionals who are maybe from some other domain and they want to really switch to the specific domain, they have this common question that, whether I'm able to cope up with the data science field or not, whether I will be able to enjoy the coding process or not. So you can take an example of this specific discussion. And now I really want Himakesh to present his work, whatever project work he has done. As he mentioned that as a part of this program, uh, I was leading this entire program first of all, and in NLP we have covered up till LSTM. Transformer is something that we're covering up right now. So he has not involved any transformer specific thing. Might be after learning about transformers, he will improvise his work further, and we will share with you the GitHub profile of his work by the end of the specific discussion. And whenever he will made an update, uh, you will just have to look onto his GitHub profile. You will find the latest work as well. But anyhow, the approach, the mindset with which he has worked, that is something we have to learn today. From this specific discussion, you will get to know that how basically in NLP specific domain, we work on any specific project. You will get a clear picture of it, and that's what we want to deliver over here. So, with that, Himakesh, I think we can start now. You can present your screen, and we can just work on, first of all, problem statement understanding.
Thank
I'm
you, ma'am.
sharing the stage now to you.
Sure.
Perfect. So, can you just present your screen, Himakesh?
Uh, can you see my screen, ma'am?
Yes, it's visible. Can you just go back to your problem statement?
Yes, yes. So
Perfect.
here
Yeah.
is the problem statement. So basically, we have to build a news mm, classifier which will classify the articles in four different classes. So the first thing is that automatically classify articles into predefined domains. And as I have talked about, we have four labels basically. And we also have to provide confidence matrix for downstream application, that how confident the model is about a certain class. And we also,
Just do one thing, Himakesh. Sorry to interrupt.
Mhm.
Just can you click on hide button below?
Yes, ma'am, sure.
Just right after stop sharing, hide button. Can you just click on it? Yeah.
Yes.
Now you can go ahead.
So we also need to generate a headline for full length article context. So the first objective is, our primary goal is to classify article into four major classes or categories, which is business, sports, politics, and technology. The second task is, as I have said, that confidence estimation. This is like an extension. Here, the system should provide prediction confidence, low, medium, high, to ensure reliability for automated search and recommendation filter. And task three is to generate headline We will use sequence to sequence and T5 small as well, because I figured out that sequence to sequence architecture doesn't give a very good, you can say, headlines when the context window gets increased. And let's talk about the data set. We have two data set, basically BCC news and AG news, and my preference is BCC news. And we have to do multiple things. So here is the workflow for that. First, we have to prepare the data for BCC news. Let me show you the data set first. So here, give me a second. In the data set, we have five columns: title, pub date, guide, link, and description. In the title, we have the headline of the news. In the pub date section, we have the date on which that news get posted. On the guide and link, both are the same thing. And in the description, we have the description about the news. You can say article of the news. And as you can see, we don't have class label over here. So we will figure out that how we will grab the class from the link we have. So I think that's it about the dataset. We should move towards the project, I mean code. So first I imported all the libraries over here,
So I
and
hope
then
that before we will jump towards the code demonstration, everyone is clear about the problem understanding part. Can we get a quick confirmation that is the problem statement is clear? Because see, when we start the project, if the problem statement itself is not clear, the complete flow you will not able to get it. So can I get a quick confirmation from everybody's end in the chat window, whosoever has joined us live? That's the benefit of live discussions, that we can discuss if we have any doubts in a live mode. So if you have any questions, please ask in terms of problem understanding, because it's a quite a bigger code he will demonstrate. So you might get confused if you don't have a clear understanding of the problem part. So any questions? Otherwise, you can give just a confirmation to Himakesh and to me, so that we will get a confidence that okay, we are good till so far and we can proceed further. Can we get a quick confirmation from everybody's end? Quickly, if we can get that, that would be great for us. Yes, great. What about others? I can see many people have joined us. All good? So, Satish has summarized it. We are analyzing the description of data and then predicting a headline for that description, isn't it? Himakesh, do you want to answer it?
we are not just analyzing the news articles. We are also classifying the news articles in either of the four classes, and the classes are
Yes.
sports, technology, politics, and I think it was. Let me check.
Technology.
Technology, yeah.
Yeah. So basically, it's a classification task, multi-class classification task, we can say. Yes,
Yes.
we are obviously analyzing it. That's how it will classify it. So classification is the correct, I would say, interpretation of this project. And second thing is headline generation. So one complete project is composed of two components. So first of all, he will showcase to you all that how he brings that classification model classifier, how he has built that end to end. And then second part, he will showcase you the headline generation part. So this project is composed of two components. I hope now it is clear to everyone, right?
Yes.
Can we get a quick confirmation? I think seems good. We can proceed further now, Himakesh. Yeah.
So yeah. So first I have imported all the libraries. So as you can see, I have imported all the libraries. So in the second tab, what I have did is, in the machine learning, I mean, sorry, in the deep learning, we have to specify random seed to make sure that we are able to reproduce the same results every time. And this is basically a garbage collector to clean the backend session. So first here over, I have loaded the dataset from the path itself, and then I printed the shape of the dataset. As you can see, the datasets consist of about 42,115 rows and 5 columns. I think it's clear. And then we did the EDA part, exploratory data analysis, in which I have just printed the head for 5 rows. Here you can see title, update, guide, link, and description. And in the column section, we have title, update, guide, link, description, which I have already discussed. And in the info, we can see that there is no null value over here. I've also did the describe part. So here what we can say is, give me a second. Yeah, so here we have title, frequency, and a unique count. And I think I don't know what it is. It is top. I mean, maybe it is the result column which have the maximum number of words probably. So here I have checked if there is any null value or not, and there are no null values. And then as I have showed you that there is no column where the labels are already mentioned. So I think why not grab the labels from the link itself. So let me show you that how we will be doing that. So let's say if we take an example of business news, you can see that in the business news we have a business written in
I
the
think,
label itself.
Himakesh, we need to zoom out a screen a bit so that everybody can see that business thing.
Yes, ma'am.
Yeah,
Is it
now it
visible
will be
now?
better. Yeah, it's visible now.
So
Yes, perfect.
so so as you can see in the links, we have business written for each specific article. So from here, I am thinking to capture the classes. So for that, I have just created a basic if else. So let's say if the first the link will get passed into this, and the link will get converted into lower cases, and then if sports is found in the link, it will return that into a sports class. If politics, then it will return it into the politics class. If business, then it will return into the business class. And if technology, it will return into the technology class. And if nothing founds, or something or anything that founds that doesn't belongs to all these four classes, it will return into others. So here I have applied the entire column function to the entire column, and then I have removed the other category because I don't want other category. I only want the four classes over here, which is sports, politics, business, and technology. And then I have combined title and description together so that we could have a much more info. And this thing is also mentioned in the um, problem statement itself, that we need to increase the data size so that we have so that I just combine title and description together. So title and description is that this is the title, the headline, and description. Give me a second. This is the article description over here. So we combine both of the thing. So after that, yeah. So here I removed all the white spaces that are present in the data, and then I only keep the desired column like text, category, title, and description, and I reset the index, and then I printed all of them. As you can see in the sports, we have about 8,395 rows. In the business, we have 2,656 rows. In the politics, we have 1,904 rows. And in technology, we have 430. Uh, as you can see, that data is highly imbalanced. So we need to fix that to have a better results or better prediction. Because if the data will be very imbalanced, model might get biased towards the sports class and might predict sports label for all the articles which we give or provide. So here I again printed everything, the head part after combining text category, title, description. So in the text part, we have title and description combined. So I just applied a lambda function to chop off every word from the article. So what I'm doing is I'm applying the lambda function to capture all the words like Ukraine, war, catastrophic, for, global, food, one by one. And then what I found is that average there is a 30 words in each news article, and there is a minimum 14 words in news article and maximum 58 words in a news article, in a single news article. And then after that, I have just also plotted the category distribution in dataset, which I've also said you above that sports category have all about more than 8,000 um, rows, where business, technology, and politics have severely low data as compared to the sports, and technology have very low data as compared to all three. Here I just plotted the word count histogram to see that, as you can see, that most of the words are between, I would say about 27 or 28. I mean all the article, most of the article consist about 26 to 27 words. This is what this histogram is telling us. Here I have plotted word count by each category. As you can see, in the sports we have maximum number of word count as compared to other class. And then we move towards the pre-processing part after completing the EDA part. So here I have downloaded NLTK to help us pre-process the text. So I have downloaded stop word for stop word removal, wordnet, so that it will provide us dictionary that can be used for lemmatizing, and OMW will help as a support file for lemmatizing. Here I define the word lematizer as a lematizer, and I define that I'm going to use the English word over here, English language. So this is a basic function which I have defined here to clean the text. So in so let's we are doing what we are doing here is, first we are lower casing all the text what we have, and then we are removing the punctuation, and then we are removing any special character from it, and then we limitize and did the stop word removal, and then I list all of them as a clean word, and then I join word back because vectorizer expect text string, not the list. So here, as you can see, that let's say we have a list of India win match, it will get converted into India win match. And I have verified here ki, is our text pre-processing is working well or not. So as you can see here, here is the article that is before word pre-processing, which is Ukraine war catastrophic for global food. One of the world's biggest fertilizer firms says the conflict could deliver a shock to food supplies. So here, after pre-processing, you can say that few words got removed like for, and as you can say this, you can say special character get removed, off get removed, and you can say that s, this s got removed. Could, no, could is there. To this pronouns got removed. After I applied that entire pre-processing to the data set, so what I did here is I have created another column which is called cleaned text, which contain this clean data. Hmm, as you can see over here, this is nothing but this is as you know that in the text we have bad text or mm, mm, data before pre-processing, and here is the same data after pre-processing. Then I did the feature engineering. I just encoded the label using label encoder, politics, sports, politics, business, etc. It will be encoded as 210, etc. And then I provided y as label encoder because this is our target. And then I created a test train split. And then I did the TF-IDF vectorizer. So for those who don't know what is TF-IDF vectorizer, I will give you a small brief about TF-IDF vectorizer. So, what does the TF-IDF vectorizer do is, let's say we have a raw text, and as you know that we have already pre-processed the text to which we lowercase the um, article, remove the stop words, etc., and then we tokenize it, and then we do the vocabulary creation when we tokenize it, and after that we calculate term frequency is nothing but that how often a word appears inside this article, inside a particular article. And then we do the idf, which is inverse document frequency. This will calculate how rare is a particular word across all the article. And then we just product the tf and idf, which will give us the feature vector like 0 1 2 0 0, like this way. And then we can use that feature vector in the models like logistic regression, svm, and naive bias. You can ask that why we are not passing the word directly to the models itself, because you should know that that model cannot understand our language, English language. So we need to convert that into a machine readable format. For that we are converting them into the vectors so that machine can read it and understand it, whatever the context we are trying to give it. And then based on that it will give us the prediction. Let's say for example there is an article which says India won the cricket match. So the we have the vocabulary like India won cricket match, government and market. These are the vocabularies we have. So what the TF-IDF do is it will give the vector like India to 0.75. It is just prioritizing those words which appears multiple times in the article itself, and then it produces a result based on that. For example, let's say India got 0.75, and then 65, and then 88 for cricket, and then for match it got 80, and for government and market it got 00. So it gives the context that government and market is not significant for a particular article. For here, for this article, as you can see that government and market is not pretty good context for this particular article. So this is what basically ऊपर ऊपर से TF IDF करता है. So I did nothing but just fit on training and testing data which I have created here, and then I printed the shape of test and train. As you can see in the shape, we have about 10,708 rows and 500 columns. And for test, we have around 2,677 rows and 5,000 columns. And then here we have created a word to vec. Yeah, we have created a word to vec embedding. I will try to also give you a overview of word to vec. This is almost very similar to TF-IDF. So let's say we have an article in X trend test, which is basically a clean text like India win match, stock market rise, government policy announced. This will get splitted into words like India win match stock market, which is basically tokenization. We have already did that in TF-IDF too. So in the word to vec training part, we will describe the or decide the vector size. So vector size is nothing but that each word will get about 100 dimension in the space for each word. And this window 5 is nothing but the model will look 5 words after that particular word and 5 words before that particular word, so that it can have a better context. And in the minimum count to give me a second, what was that? Yeah, so it will ignore any words that is appearing only once, and any words that are appearing more than once, it will count it. And then it will look at the context word, and let's say if there is a word India, the model will think that it might be related to win match. If it is market, it might be related to stock and rise, and if it is policy, it might be related to government announced. So it will learn relationship between words, create word embedding. Based on that, it will create word embedding, like India will have 100 numbers, match will have 100 numbers, a market will have 100 numbers, and policy will have 100 numbers of vectors. And then we have a word to vec model. Uh, and we can use that word to vec model further into our models like you can say LSTM. So here what I have did actually, this is the whole line of code over here. So I have decided a vocabulary size. I'm going to keep about 10,000 vocabulary size, in which the maximum length of each article would be not more than 120, so that each article will be represented exactly with 120 tokens. And then we have this tokenizer. We will tokenize every word, and this OOV is nothing but out of vocabulary. Let's say if our article have some words that are not in the vocabulary size in 10,000, so it will label it as OOV, so that machine understand that this particular vocabulary is not in the article. So and then based on that, we have created a fit the tech fit the tokenizing keras on extrend test, and this will create a dictionary of by learning vocabularies. And then this is text to sequence. This converts text into sequence. So basically, the keras already contains tokenized object in the form of dictionary. And what this will do is it will uh, in the text to sequence, it will convert the text to its corresponding number. For example, let me show you that. I don't know if we have example over here or not. No, we don't have example over here. So I will tell you what it is doing basically. So here in the Kera sequence shape, we have about 10,000 708 you can say rows and 120 columns, and the size of word to vocabulary is about 10,366. And here we comes towards the classification model, because we prepared our word to vec and TF-IDF, and we can now use this to integrate into our model, and can train our model to have a probabilities or predictions. So here I am using multiple models like logistic regression, multinomial naive Bayes, random forest, and XGBoost classifier, as well as LSTM classifier. I will give you a brief overview of all the classification model. So first we have logistic regression. Logistic regression is a simple linear classifier which tries to create a soft boundary across the classes. So here I did the maximum iteration equals to 1000. So it will try to iterate 1000 times to create the best possible soft boundary between the classes. Random state equals to 42 to get the reproducibility, and class weight equals to balance is very important thing, because as we know that our classes are very imbalanced, so this will make sure that each class will get equal weightage. And then I fit the model, and here are the results of logistic regression. I will uh, compare this result in the model evaluation section. And then I have also applied the multinomial naive bias. This is basically a fast classifier, uses probability and Bayes theorem. It basically look for words like stadium and learn that it belongs to a sports class or any of the class. And then I have used the random forest. A random forest is nothing but we have multiple trees together which made voting together, and based on majority vote the class is predicted. XGBoost is almost similar to random forest, but instead of collectively voting for classes, it sequentially votes for classes and it correct each other to have a better prediction. And here I have used a DL model, which is LSTM classifier. So LSTM is a neural network designed to process sequential text data, and it processes text data like a human do and understand word order and context. So here I will also give you a bit overview of LSTM. So let me check if I have, yeah. So what here I will do is, as we know that we have padded the words, let me show you. Yeah, so here padding. So what the padding does is, let's say we have a text which is of 10 word and there is a text which is of 5 word. So if we give our model a text of 10 word and a 5 word, our model might think that 10 word text might contain more weightage. So in that case, a model might get biased. So to prevent that, what we will do is we will do the padding of each word. So as you can see in the padding, we use the post padding. So what does the post padding do is, it will let's say there is a word of word which contains, there is a word which contains 5 characters. It will uh, it will adds 5 zeros in the last and the ending of that particular word, so that model don't get biased and will have a equal size of embedding for every word. This is what basically the padding do. So let's say so here I have shown you that what is padding. So let's say there is a word which only contains 3 characters. So after 3 characters it will add a 00 at the ending, so that every word which are going through the model have equal length. And here we have the embedding layer word to vec. These 25, 65, and 91 is nothing but the vectors, and tokens of the word. And each token of words contain about 100 vectors. And here I have used bidirectional LSTM. There is almost no difference. There is a very slight difference between bidirectional LSTM and normal LSTM. So what does the bidirectional LSTM do is it will read the sentence from left to right like the human do, and it then again it will read the sentence from right to left just to have a better context. So I have created two layers of bidirectional LSTM. The first layer contains about 128, mm, yeah, 128 memory size, and the another bidirectional layer contains 64. And in the return sequence we have true over here and false over here. So what does the true it does is it will return the sentences which it will learn, and then it passes to the next layer, and this will return the this won't return the sentence, this will return the words, and this will again get passed, and we have dropouts over here so that our model won't overfit. And I have again described the dropout over here and here. And then I have used N64 activation as ReLU and kernel regularization as L2 regularization. And then I'm passing a label encoder classes, which is nothing but the labels itself, which are sports, technology, politics, etc., and an activation function, which is softmax activation function. Then I compile the model with loss, optimizer, and matrix as accuracy. And then I also describe the callbacks like early stopping, and then uh, a reduced learning rate feature, and also, and then I incorporated all those in this LSTM model. As you can see over here, I have incorporated callbacks, validation data, batch size, and X-train pad and Y-train. So here I'm training the here I train the base by LSTM model, and accuracy is about 84% and val accuracy about 92%. And as you know that we have a problem of class imbalance. So I have also tried to train one more LSTM model, but with class weight. So here I have described a class weight LSTM. What it will do is nothing but I have called a function which is compute class weight. It will automatically balance out all the classes. As you can see here, we have multiple classes like 0, 1, 2, and 3. So we have 4 classes, 0, 1, 2, and 3, and each class has got weightage. Here you can see 1.25, it got the weightage of 1.25, 1.75, and this got weightage of 0.39. Why low? Because this must be sports class. As we know that we have a very huge number of data for the sports class, so the model decreases its weightage. And here you can see it have a much more weightage. This must be technology class. After doing that, I have incorporated that uh, class weights into this LSTM model. This is the same model over which is above. I have just added the class weight as class weight dictionary over here, and then I saved the model for future run. So here are the results of. Here I achieved a little bit less accuracy than the above one. Here I achieved about 88% accuracy. Here I'm comparing base LSTM, LSTM plus class weight versus logistic regression. So here I described a very small function for LSTM base, LSTM class weight, and logistic regression. Mm, uh, Look, this might confuse you. So I have pasted all the information in the markdown format. So here, as you can see that in the base LSTM, we have a pretty good accuracy of 94%. But as you can see, when we look closer, we might find out that in the specific technology class, it fails to uh, classify technology very well because the precision is very low, recall is very low, and the balance between and recall, which is F1 score, that is also very low. And so here I have compared it with the class weight model. As you can see here, we have a massive jump in terms of recall in the particular technology class and have a bit better F1 score. Here we have 0.16 and here we have 0.35. But the precision drops a bit. Here we have a precision of 0.28 and here we have about 0.24. And accuracy also dropped a bit. But this improves a model a bit and this satisfies that our model is suffering from the class imbalance. That's why uh, it is not confident about the technology specific class. And let's move towards the logistic regression model. So this is the classification report of logistic regression model. It has the highest accuracy, but again, we shouldn't look for the accuracy always itself because sometimes accuracy fools us. And this happens with me too, especially in this project. And as you can see, we also have a class imbalance in technology over here, but the precision and recall are pretty good and balanced as compared to a base LSTM and LSTM with class weight. I did the model evaluation part in which I have compared the uh, results with all the models, and here you can see the results of all the models. So logistic regression have the maximum accuracy as compared to all the models, and even the F1 score is uh, very almost best as compared to all the models. Here I have plotted the confusion matrix for logistic regression. As you can see over here that for uh, give me a second, yeah, for business class we have business class is predicted about 472 times true as business class, and politics is predicted as 352 times correctly, and sports 1663 times, and technology 61 times. uh, as you can see that politics and between the politics and business model is getting bit confused because sometimes what happen is article of politics and business looks pretty similar. That's why the model is also finding those patterns, and it also thinks that business and politics might overlap. So this there is an important observation that this experiment taught me that accuracy alone can be misleading, and this is the case for me. Previously I thought that LSTM might perform better because this is a deep learning model, but this is not what always happens, because what happen is not only the model creates the better result, sometimes the data set, what problem we need to solve, that will be the reason to select the best model. So as I said that I thought that Pace LSTM will be the best model, but I was missing most technology article looking at precision recall and F1 score help me identify this issue and help me select the best model. So here I have described a confidence estimation module. So this is the second problem we need to solve. Mm, Here, as you can see, we have task 2, which is confidence estimation. So the system should estimate prediction confidence low, medium, or high to ensure reliability for automated search and recommendation filter. So here I have defined mm, a module to return all these text classifier, vectorizer, and label encoder into the dictionary. So here it will pass text. Classifier is the model. Vectorizer is either word to vec or IDF, and this label encoder is nothing but all the four classes. And here are the cleaned. Here I cleaned the text. This module is already defined above, which I have showed you that I have already cleaned the text all. And then this vectorizer transform will convert text into TF, IDF, where vocabulary were already learned during training. That's why we transform it. And here we'll get the probabilities for, let's say there is a word, and here we will get the probability for each word or each article. Let's say there is an article, it might be chance that 5% it belongs to, let's say, give me a second, yeah, 5% chance that it might belongs to business class, 2% chance that it might belongs to sports class, 90% chance that it might belongs to technology class, no, political class, or 3% chance that it might belongs to technology class, like that way. Here I am, what I'm doing is, let's say we need to find the best probability. So we need to grab this probability from this list. So I'm saying I'm calling numpy argmax to grab the best possible probability, which is 90%. And then we will convert index back into level. For example, as we know that 90% is for sports maybe, so it will convert that into the sports. And here it will multiply that 0.90 to 100 to have a percentage of confidence score. Here I have described a basic confidence level logic. So let's say if there yeah, so what I did is, okay, let's say there is a mm percentage which is about 86%. So we need to round off to 90% because uh, we need to pass it into this confidence score to have a better classification of scores. So let's say there's a confidence score which is above or equals to 80%. It will say that it is a very high confidence score. And if it is around or equals to greater than or equals to 50%, then it will say medium. And if it is or either it will say below 50, it will say low. And then I return all those class over here predicted, which will return class, return score, percentage, and this will return the confidence level, high, low, medium, etc. And this will return the probability. I mean, yeah, it will look for classes, then probabilities, then zip them into the dictionary, which we will showcase later. So here for the demonstration, I have took some example. So there are 4 example basically, and I have put those all example into the list, and I have predicted all those by calling the function here. And as you can see here over here, so we have the prediction over here. Let's say there's an input text which is the government passed a new tech regularization bill affecting major technology firms like Apple, etc. And this is predicted technology, and which is correct, and with a confidence score of about 89% or 90%. And here it shows that confidence level is high because it is greater than 80%. And it also shows the class probabilities. So it shows that it 9.5%, 9.55% it belongs to business, 0.93 it belongs to politics, and 0.22 it belongs to sports, and 89.30 it belongs to technology. So as I have said that here we have described a numpy argmax which graphs the maximum probability for a specific class. So here what it does, it is printing all those with their respective classes. Here's a second example. The champion player scored a stunning goal in the final minutes. This looks as a sports. This article must belong to sports, and as you can see that it also predicted it as sports, and with the confidence score of about 98%, and confidence level is also high. Mm, and we have a news of business. Basically, the Federal Reserve announced a 50 basic point interest rate cut to stimulate economic. This belongs to business class definitely, and it also predicts is at business. An example for we have a Microsoft says its new quantum chip is vastly more reliable than its previous version. This definitely belongs to technology, and the model also predicted as technology, but it has a little bit low confidence. Why? Because it think that it might belongs to politics, sports, and businesses as well. Maybe it has some words that belongs to, let's say, commercially may belongs to business, right? And yeah, just say these words like notoriously delicate and unstable might belongs to business or politics. That's why its confidence score got a decrease a bit. So here, now let's move towards the another task, which is headline generation. We need to utilize sequence to sequence architecture to generate the headline. So this is pretty big code, very big code. I will try to make you understand by giving you overview. मैं मोटा मोटी आपको बताऊंगा ऊपर से कि how this sequence to sequence is actually working. So in the sequence to sequence architecture, we have encoder, decoder, and a context vector which is connecting those encoder and decoder. And in the encoder itself, it contains a LSTM model. Both the encoder consists of LSTM and the decoder itself too. And the work of encoder is to get the input, and the work of decoder is to throw the output. So let's say there is a word which is heavy rainfall in Bihar caused severe flooding. 20,000 people were evacuated. Rescue team were deployed. So this is the article, and we need to predict the headline for it. And we want the headline to be look like this: Flood displaces thousands in Bihar. So when it goes in the encoder, first it will first the both the memory state uh, H0 and C0 will be 0, because at time 0 the both will be 0, and let's say at t equals to 2, H2 and C2 have two words like heavy and rainfall, heavy word and rainfall, right? Then the LSTM will think that this heavy and rainfall might belongs to weather event. Okay, and then after as the time pass out, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15, so when time equals to 15, when H15 and C15 uh, uh, we move to the H15 and C15 cell, we have a final memory which will be like, let's say, disaster. That flood is similar to disaster. Bihar is a location, and thousand which are people affected, and severity is very high. So these are the assumption that the LSTM model made based on the article we have, right? So what it does, it passes this into the context vector. The H final and C final will be passed into the context vector. This disaster, Bihar, thousand, and high. This will get squashed. I mean, yeah, scaled and passed into a context vector. It won't get passed in the same format. It will get passed into this format like 0.44 minus 77 in the form of vector list. And then based on that, the decoder will try to predict each word. Let's say if it predicts the first word as Bihar, sorry, flood. Let's say it predicts the first word as Bihar. So the model will penalize it. It says that in the context vector that this shouldn't be the first word. So it will again predict the next another word. So by doing the same thing again and again, and through the back propagation, it will be able to predict the word which is for flood displaces thousands in Bihar. And what we do is, here is a difference in decoder LSTM. It starts with start by printing start and ends with by printing end. So that model understand that when the output has to start and when the output has to stop. That's why we have this start and end at the starting and end of the article. So here is the flow. So basically, let's say there's a as I've described already above, that this is the article. The article is gets encoded, converts into word, into vector, and that and the H final and C final, that goes to context vector, and context vector vectorizes them. And then in the decoder, with start and end, it prints the headline between them, like flood displaces thousand in Bihar. And so this is what we have. So we also have inference pipeline over here. I will also describe the inference pipeline. So what the inference pipeline do is, it will take the article text, what we have over here, this, and then it will lowercase it, strip it, basically pre-process it. Then it will convert the text into sequence, the numbers basically, and then it will tokenizes all the uh, text or sequences, and then it will add the padding sequence, post padding, which converts length of article to a fixed length. Then we will do the model predict. So after prediction, will have the state H and state C memory. State H and state C is nothing but a long-term memory and a short-term memory. And then it passes it to decoder. Decoder starts by target sequence, which is SOS token, is nothing but start of the sentence, which I have showed you over here. This is what it is: start of the sentence and end of the sentence. So the decoder knows that when we need to start and when we need to stop. And then we predict the model using the target sequence, which is SOS, start of the sentence token, with having two states, the state H and state C. Then we will have the word probabilities. Again, the same thing. We have four word probabilities for each article, and then using R max, we will grab the maximum probability, and most likely word will be gets printed. So basically, this is a sequence. As we know that LSTM is a sequence model, this will predict headline one by one. For example, it will predict headline like flood, displays, then thousand, then in, then Bihar. This will happens again, and let's say, so it will append the word. Once it predicted first word, it will append the word with another word. Let's say it predicted flood, then again the model will run and it predicted displaces, then again thousand, then in, and then Bihar, and all these words get appended word to headline, and then use predicted word as next. And again, let's say we have two words, we will again put that two words in the memory itself, the state H and state C, and then again the new words gets predicted. So what I'm saying is, okay, let's say the model already predicted flood and flood displaces. So the memory state already have flood and displaces. Again it will throw this, again it will use this cell state to predict the next word, which is 1000. This will happens until it reaches to the uh, end of state token, which is the end of when the which is the end of the sentence. And then it will join all the words and generate the headline. This is what basically happen in sequence to sequence. So this is all happening in this code. I trained this model and the accuracy wasn't very good. It is 24% and val accuracy is 21%. This is not good. I have also tested this. So here is the, let's say there's a description. Price for everyday items could go up at a time when the cost of living. I wanted to interrupt. Ma'am, can you listen me? Hello.
Yes, yes, I can listen you.
Oh, okay. Thank you, ma'am.
Yes, please proceed ahead. Doing
Yeah.
well.
So
I'm
yeah.
impressed.
Thank you, ma'am.
Yeah.
And then we have a description. So here is a description, which is prices for everyday items could go up at a time when the cost of living is already rising. And original title is five ways the Ukraine war could push up prices. And look at what the headline it generated. It generates how is the UK inflation rate and how much is it and how much is. So as you can see, the model is hallucinating and not able to generate the headlines properly. It should generate the title like the headline like this: five ways the Ukraine war could push up prices. So again, so here we have the another example. Joe Perry beats Judd Trump 9-5 to win the Welsh Open title. And the original headline for this is Welsh Open, Joe Perry beats Judd Trump to win title. And look what it generated. World Cup 2022-2022. England versus South Africa and England versus England and England and England. So it get hallucinated. Mm, and the same goes for all the result. It doesn't perform very good. So I thought, what should I incorporate instead of sequence to sequence? There's a major problem with sequence to sequence also when we have a very large article. So as we know that the sequence to sequence reads the article word by word, sentence to sentence. So by the time it ends to the last word, it might forgot that what was the first word. So we should have a very limited size of um, article to generate better output or better headlines. So here what I did is uh, I used a T5 small model to generate a headline. I will also give you the overview of how T5 small model is actually working. So here is the basic brief overview that T5 is pre-trained on massive text corpus. Corpus is nothing but massive text data. Already understand languages, produce more meaningful headlines. So here we are doing parallel processing in T5. No, no, no. Sorry, we didn't have a parallel processing. Here is the flow one and here is the flow two. So here first we have the BCC dataset, the description, and in the description we will add a prefix. Prefix is summarized so that the T5 model understand that we wanted a specific task to be done, which is summarizing, because a T5 can do a lot of things, and I wanted specifically to do the summarization. So we have the input text as article. For example, summarize Microsoft launches a new quantum chip. It will tokenize it first and then convert words into tokens ID, then create a data set and data loader, then feed that into a pre-trained T5, and then it will predict the headline. compare it with actual title, then it will calculate the loss, then it will do the back propagation and update the weights, T5 weights, and repeat it for multiple epochs till we have the fine tuned T5 model, which will be trained on our BBC News dataset. So here is the inference pipeline. So let's say we have a new article, okay, and then we will add a prefix as summary, as we have seen ever. We again convert that into the, this will be the same thing will be happen. This is just for generating the headline, this is for training the T5, and this is for the generating the headline.
Acha, one thing.
Yes, ma'am.
I think in the starting of the session, I said that he has not implemented transformer thing,
Yes,
but
ma'am.
just now because he already have worked on T5 as well,
Mm-hmm.
so it is a transformer based model only. So if you will
Mm-hmm.
learn about it, it's a pre-trained model which he has used, where we both have encoder and decoder in it. So yes, there is a parallel processing happening internally, and usually right now we don't implement the transformer based architectures from scratch, because that is kind of a computationally heavier task and difficult to implement, and we have the pre-trained models available for the transformers. So what he is showcasing us right now is a transformer specific model only. So amazing, I was not expecting this, but he has done this as well. So yep, you can continue now, Himakesh.
Thank you, ma'am.
Great.
So I have basically give you the overview of that, how the flow of T5 is working. So I did the same thing. I do the fine tuning on my dataset, the BBC dataset, for almost 10 epochs, I think. And then I tried generating the articles from it. Let's say I have taken an example of index 145. So it has a description which is, the country may be about to default on its debts as Western sanctions over Ukraine bite. So the original title for this is Scotland's World Cup playoff against Ukraine postponed. And the generated headline is, the country may be about to default on its debts as sanctions over Ukraine bite. As you can see that there is not much difference in description and generated headline. I still don't figure out that why this is happening in the transformer, but this gives a pretty better result as compared to sequence. Look, I didn't knew that this is going to give me a perfect headline. I was just experimenting that what could be the better than sequence to sequence. Then I come to know about the T5, and then I implemented that. I didn't knew that the results will be mind blowing, something like that. But uh, this is not the result I was assuming, but it's okay. And then I did nothing but model saving. I saved all the models so that I can use that for the Streamlit interface. And I have created an inference pipeline over here for all the models so that I can use this in the Streamlit itself. Now I will show you the I think I will show you the my Streamlit application. Should I move forward to showing my Streamlit application?
Yes, I think we can proceed further. Yeah.
Yes. So give me a second. I might have to check something.
So, in case if you guys have any sort of questions about this entire project, I think now you can see that how amazingly he has built everything end to end. And the main difference between the people who copy the code versus who understood the concept and then implement on their own is this. You can see the explanation of him. He knows every bit of what he has done. And again, I am repeating the fact that he was not from this background. So he has learned on the way, he has experimented, he has researched on his own, and obviously by learning from live discussions and doing his own self exploration on top of it, you can see how amazingly he has worked around with it and how much knowledge he has gained. So considering he is a fresher, considering he has just learned new all these things, uh, I mean, I'm amazed to see this kind of things, right? So please do appreciate and take it as an inspiration, that okay, things can be possible. If we pay attention, if we do consistent efforts with respect to whatever we want to learn, we can do it, right? So what you are searching right now, with Gemini, Himakesh?
I forgot it, the terminal code. What I should.
Ah,
Actually, I know,
okay.
but I don't know the exact syntax that how to look it to the particular directory. Because
Okay, you can
PowerShell
just have a
and
look onto it. If you can
yeah,
just have if you can share it, that would be great. Otherwise, maybe we can uh, avoid that.
I will
Just have
show
a
you.
look onto it. And in the meantime, if you guys have any questions, any doubts, you can just let us know.
So I did nothing, but I
Uh,
just pasted my app.py streamlit app.py location into the Gemini and asked to write a PowerShell code to open this Streamlit
mhm.
app. So it writes the code. I know actually how, but I forgot it that the indentation. I don't want to write it always, and it is a pretty big big code to write. That's why I just copied it from the Gemini itself.
So it opened now.
Yeah, it is opening. Yes, okay.
Okay, let's wait for some time. Yep, it was a very big discussion today. It happened. So maybe the people who will see this discussion after this session will get over. And in case if you guys face any sort of doubts, any sort of issues, you can let us know in the comment section, and then we will look onto the comments and we'll see that if there is anything which maybe I myself or Himakesh will help you out. Will definitely help you out in that context.
I think
I think he's working on it in terms of loading the website.
I think the one of the file of the model got deleted somehow. I don't know. Let me check. It was working in the morning.
It's okay, it happens. You can just have a look onto it. If it works, that would be great. Otherwise, it's okay.
By the way,
Yep.
I can
Any
still
questions, any
show it.
doubts anyone is having? Yep. Sorry, Himakesh, what you are saying?
Ma'am, I can still show the recordings. I have the recordings actually of this. Actually, the thing is that
Uh,
somehow this particular pickle file classification model got deleted. It is not found in the directory.
okay, it's completely
Hmm.
fine. Uh,
So if you allow me, I will show you the recording of that I have already recorded. I must have the
okay,
video.
you can just open that. And I'm not sure ki whether the recordings will be audible, but I think we can see. You can just open
Yeah,
it if you have that. Otherwise, if that was also not possible, maybe we can just share the files with them. They will run and execute the code and deploy it in their own system.
I think I don't have the recording now.
I cannot see any questions. I think um the session was very big. That's why many learners, maybe they have a confusion, or mm, people are still here. There are many people who are here. Yup. Have you guys enjoyed the entire discussion? Is this something which is uh, encouraging for you all? In case of any questions, I'm again saying please post it in the chat window till the time we are live. And once we leave the discussion, do let us know in the comment section that whether you enjoyed the entire conversation or not. And if not, if yes, sorry, then please let me know. I will try to conduct these kind of discussions more often with my learners.
So, ma'am, I think the file is not in the it's in the directory. I think it might got deleted. It might got deleted. That's why.
It's okay. It's okay. Maybe let's avoid this in that case. So, what you guys can do, we will share the file with you all. Himakesh, you can just have you uploaded in your GitHub.
Yes, ma'am.
So he will share the link with me. I will upload in the chat of this YouTube. Uh, you guys can have a look onto these files. You can work on top of it, right? You can make further enhancements. I hope that you got a very good idea about this entire project. And obviously, you can do way more about this specific project now, and you can optimize it at your end. Further, he showcased me in the last conversation his website look as well. Maybe by mistake he has removed it. It's okay. So you can just try to deploy your work, whatever you have done via Streamlit, and you can use other interfaces as well. But yep, after deploying the things, it should look fine, and you will be, whenever we are writing, let's say, any of the news headline, so it will, your model will be automatically able to classify whatever be the best model you are getting, that whether it belongs to, let's say, technology class, or whatever be the classes he has. I think four categories he has differently
Yes, ma'am.
showcased: sports class, right? And after that, when, let's say, I'm writing a given text, it should be able to generate a headline for me, that interface. So that is the same, that is the final product which I'm expecting from this specific project. So please work on it at your end. In case you are facing any doubts, you can reach out to Himakesh directly as well. His LinkedIn profile is attached in the YouTube description, right? So you can connect with him. You can ask him the questions. And if there is anyone who is listening me live and maybe join, watch this entire recording after the session will get over, and is interested to showcase his or her work also, whatever project they have done, you can reach out to me. You can find my email ID on my LinkedIn profile in the about section. I'm happy to host you as well, right? Seems like there are no questions, Himakesh, so we can wrap up the discussion for now. Any last words you want to say to the audience?
Ma'am, I just wanted to thank you for the opportunity you gave me to present my work on the YouTube platform itself. I didn't know that I belongs to. I mean, I came from a field where I didn't have the computer science, and I have. I think I did the pretty good job. That's why I'm here presenting my work on the YouTube on one of the biggest platform of yours, ma'am.
Yes, definitely. You did a very good job in terms of implementation, also, and in terms of explaining the work as well. Uh, and as a mentor, I feel very proud when the freshers like you learn, experimented, have that spark of getting more knowledge towards the specific field. And it takes a lot of effort and guts to come on stage and to explain it to everyone. But I hope that this experience will be helpful for you in future when you work in the industries. Now
Yes, ma'am.
you might gain a lot of confidence in terms of sharing your work to the interviewers as well in future. And you never know, maybe some interviewer might see your recording, and they will reach out to you to further give you more opportunities in their company. So we never know, right, from
Yes,
where the opportunity will come.
yes, ma'am.
So with that, thank you so much, everyone, for joining in. I will see you all in the upcoming discussions. I hope that you have enjoyed this entire conversation. If you do, please encourage the learners, please encourage these students by writing the feedback in the comment section of this video. And definitely, I'm pretty sure Himakesh will also see all those comments and the feedbacks.
Yes, ma'am.
With that, bye bye, everyone, and see ya.
Thank you, ma'am, and thank you, everyone.
Thank you. Thank you. Thank you.